So we left off here in carbon monoxide, and I'm going to be moving on to the next primary pollutant. Oh, this is an effect of carbon monoxide. Just know that it's related to your hemoglobin or red blood cells. Carbon dioxide, also colorless and odorless as well. And it's basically one carbon and two oxygens. And most of carbon dioxide that's placed into the atmosphere is a result of the carbon cycle. A lot of textbooks won't put carbon dioxide as a primary pollutant, and you'll see here because it's kind of showing that it has to react with oxygen in order to produce carbon dioxide. But we know that when you have any burning of organic matter, please add that, burning of organic matter, you're going to release carbon dioxide. So why is it such a big topic in environmental science? Well, since the Industrial Revolution or industrialization, we've taken fossil fuels that were once buried and we've taken them out of, or we've introduced them into this cycle of carbon that's supposed to be natural and caused excess carbon dioxide to be into the atmosphere, which is going to lead us to one of the topics we're going to talk about as a global air problem, which is global warming or climate change. So you have a considerable amount of carbon dioxide or excess amount of carbon dioxide in the atmosphere due to burning of fossil fuels, and this results in global warming or climate change. Nitrous oxides also are produced from the organic burning. Remember that 96% of your body is composed of CHA and PS, so all these primary pollutants where you see the nitrogen and oxygen, carbon, hydrogen are going to be released through organic burning. Burning fossil fuels is a big contributor to nitrous oxides, and here's the reaction again. Major source is automobiles, and you see here motor vehicles are 49%, and the nitrogen cycle, of course, emits excess amounts of nitrous oxide. Sulfur oxides, colorless, irritating odor. Remember that sulfur is the one mineral that you could probably detect from the way it looks and smells. 90% comes from electricity production. So although most of our primary pollutants result in cycling or car exhaust or cars fuel, sulfur comes from the burning of coal. And of course, there's still a portion that's emitted from the cycle. We're going to get into the explanation of this diagram in the next couple of chapters. Here are some effects. Sulfur is linked to acid rain, and so is nitrogen, so I left them together. We're going to talk about that in a minute. They both are responsible for smog in the troposphere. They both deal with respiratory conditions, and obviously any primary or pollution in the atmosphere is going to cause irritation to your lungs, eyes, nose, etc. Volatile organic compounds, the word pretty much says it all. It is organic compounds, and most are going to be hydrocarbons. We know organic is going to be 2 or more carbons, while hydrocarbon is a volatile organic compound. Its incomplete burning or evaporation causes hydrocarbons or volatile organic compounds to be emitted. Burning of fossil fuels and vegetation are a direct link to VOCs, but also you need to reference paints, cleaners, solvents, aerosol spray cans, and dry cleaners, as I showed you the picture here to remind you, also are linked to volatile organic compound emissions. And here's a breakdown of how, this is from the EPA. Remember I took you to that site and you could see which type of activity leads to each type of gas. They're going to weaken your immune system and central nervous system. They again, are going to lead to respiratory issues, as I'm showing you here, or kidney and liver damage, irritate your eyes again, cause nausea, headaches, and they are linked to leukemia. Remember, sometimes you need to know specific diseases and kind of giving you some to reference. The last primary pollutant is particulate matter. Sources are going to be, or really by definition, it's any suspended particle, and it could be found as a liquid or a gas. So here you're seeing dust, forest fires emits particles, sea salt is considered particulate matter. Burning of fossil fuels or production of goods in industrial plants is going to lead to particulate matter. Cars, paved roads, or any kind of construction is going to lead to particulate matter, as well as mining. So 62% of all particulate matter is going to come from natural sources, which is everything I'm referencing on this side, like the dust, the fires. Remember, fires don't have to be natural. They can also be, obviously, man can cause fires or start fires. But naturally occurring, 62% of particulate matter comes from naturally occurring events or cycles in nature. 38% are what we do, like burning fossil fuels, mining, or construction or urbanization. Here's a picture of a lung with some particles inside of it. Just a picture of, obviously, remember, any air pollution in the troposphere is going to lead to respiratory damage, eye irritate, and things of that nature. So what decreases our pollution in the atmosphere? If a particle is heavier than air, it's going to settle due to gravity, so it's not going to make it to the troposphere or lead to pollution. Any type of precipitation will dilute particles or cleanse them or move them away. Sea spray can wash out particles. Wind will wash out particles or dilute or decrease the pollution in a specific area. And chemical reactions, remember that all these pollutants are going to react with each other and hopefully break down or break apart. These are factors that increase pollution. So urbanization or urban buildings are going to increase pollution or cause pollution to be stagnant in a specific area. They slow down wind and reduce dilution, so tall buildings do that. Hills and mountains will do the same thing. High temperatures or increased temperatures promote chemical reactions. And volatile organic compounds, remember VOCs are volatile organic compounds, from certain trees will increase pollution, like oak or kudzu. Vines will increase pollution. The grasshopper effect is a term that you need to understand. When pollution is transferred from from tropical regions, which is where heat is or temperatures are higher, so that means pollutions are more concentrated or more prone to chemical reactions, and they're transferred to the polar regions, which you shouldn't see such intense pollution. That's called the grasshopper effect. And finally, temperature inversions, which I'm going to talk about in the next video, will also increase chances of pollution. This is because when you have temperature inversions, the lower levels of the troposphere reverse from the middle. So let's say normal temperature should be hot and then cooler air is above. When the cooler air is below the warmer air, the pollutants travel up and end up being pushed back down closer to the lithosphere, so they stay stagnant in the troposphere. Again, I'll go over that tomorrow and show you the cycles that go with it.